graphing linear systems. We are starting a whole unit on systems of equations. It's kind of a nice unit because you're solving for where two equations intersect, all right? And so we're starting with the graphical interpretation of it, which is kind of nice. And we'll come back to graphing every time that we learn something new. What we're finding is where two lines intersect, the point that they have in common. And the nice thing is, this is a fantastic test where you will know if you got 100% by simply plugging in your answers and checking your equations, okay? And this is exactly how things worked not last year, but years ago when I would teach Algebra 2. You either got 100% on the test or you got a 20%. There was no in between because you had the students that checked their answers and you had the students who didn't, okay? So it's a kind of a great test if you take the time to make sure you know how to check. Now today, you don't have to check every single answer. I'm going to show you how to check in notes, okay? You don't have to check every single answer, but you need to know how to do it. So I encourage you to check the answers for 2 problems or 3 problems. Know how to check. But you don't have to do it for every single problem, all right? And we'll keep working on checking answers starting next week. Plugging in and checking. So here we go. Example 1, graph the system and check your solution. And again, it says check, but you need to know how to do it. Check 2 or 3, just so you know how to do it by yourself so that you can do it on a test, okay? I'm going to show you how to check by hand. I'm going to show you how to check using your calculator. But it's really easy just to plug in the numbers. Your worksheets today have graphs on them, okay, which is super nice. So during notes, you make a little graph, a little chicken scratch graph will be fine. But your homework is nice, and that's why I copy worksheets off, is just because there's graphs on there. So it makes graphing so much better. Okay, graph the system and check your solution. I encourage you, if you have colors, 2 colors, that's very helpful. I do have markers in the back on the round table if you would like to grab 2 colors just to help you graph. I think that's kind of a nice thing to do. And keep track of which line is which. So I'm going to use 2 colors. What form? Oh, I didn't want to use black. Black is boring. Purple, much more interesting color. Okay. Purple here. What form is this equation in? Y-intercept, slope-intercept form. What is slope-intercept form? Y equals mx plus b. This is the form I want you graphing in today, which means if our equation is solved for y, then we're good to go. If the y is not by itself, then we need to do a little bit of work, okay? And it's important that you know how to solve for a variable correctly, because we're going to do more of that on Tuesday. So this is in y equals mx plus b form. And where do we begin then? Yeah, we begin at the 5. On the y-axis, I'm going to make a big beginning point at 5. And then the slope is -2. And what does that -2 tell me to do? You want to turn it into a fraction. How do we turn it into a fraction? Over 1. So now what does the slope tell me to do? Down 2 and right 1. Ladies and gentlemen, you should put the arrows on there to help you out. The bottom number always tells me to go to the right. The top number will go up or down based on the sign, okay? So I'm going to go down 2, right 1. And I'm going to encourage you on your work today to make these little stair-step points, down 2, right 1, for the entire graph in both directions. So if I can go up 2 and back 1, I would also do that. you make all of these intersection points, you can tell exactly where the lines are going to intersect because you've taken the extra seconds to plot those little intersection points that are super nice. Everything today should intersect super nicely. And if it doesn't, you've made a mistake, okay? So I love these worksheets because they're going to make sure you know how to graph properly. This second equation here is in slope-intercept form. Y equals mx plus b. Where do we begin? -2 on the y-axis. And what's the slope for this pink line? Up 3 over 2. Up 3, right 2. So again, make those arrows. They're really helpful later on. We're going to count up 1, up 2, up 3, over 2. Oh, 1, 2, 3, over 2. And since I made that point, took the extra time, I can see that my two lines intersect really nicely. Right here, what is this ordered pair where these two lines intersect? 2, 1. Ladies and gentlemen, that is the solution we're looking for. We want to know, where do those lines intersect? What point do they have in common? Okay, write down that ordered pair. I find that a lot of kids still don't know how to plot a point. The reverse would probably be true. When you label a point, you should label the x-axis first. We're at 2 on the x-axis, and we're at 1 on the y-axis. Those are x and y values that we can plug into our original equations. I'm not going to do that for this one, but I'll do it on the next equation. All right. I'm going to write this other equation to the side here. X minus 2y equals 4. So I'm just writing that equation here just so we can show how to solve it. All right. I need to take this equation, x minus 2y equals 4, and is it in slope-intercept form? No. What should we do to get it in slope-intercept form? I want to move the x. How do I move the x? Okay. So it's a positive x right now. I can subtract the x to the other side. So I have negative 2y equals negative, I'm going to put a 1 in there because there's no number, but there is always a 1. So negative 1x and a positive 4. And then how do we get y by itself? Divide by negative 2, divide by negative 2, divide by negative 2. I hope you're showing these steps because you'll have to do it. What is a negative divided by a negative? Positive result. So that's going to be a positive 1/2. 4 divided by negative 2, a negative 2. Positive divided by negative is negative. 4 divided by 2 is 2. So here is our equation in slope-intercept form, where we have the m, the slope, and the b. So where do we begin? Negative 2 on the y-axis. And then what's the slope telling me to do? Sincere, what does the slope tell me to do? Up 1 and right 2. Love that. Thank you. Up 1, right 2. Up 1. Oops, right 2. Up 1, right 2. Up 1, right 2. And again, I am extending. I only extended to the right, but I need to go to the left as well. So I'm going to go in reverse. Down 1, back 2. Extend the line in both directions as far as you can go. All right, ladies and gentlemen, make sure your line extends in both directions. They go on forever. You can staple it and just put it in the red bin right there. Thank you. Okay. All right, this second equation right here, x plus y equals 4, is it in slope-intercept form? No. How do we get it in slope-intercept form? subtract the x, subtract the x. So we have a y equals, again, a negative 1x. Again, there's no number there. You can always put in a 1 and a positive 4. So here's my equation in slope-intercept form. Where do I begin? At 4. Begin at 4 on the y-axis. Put a nice big dot there at 4. And then what's the slope? Negative 1 over 1. I love how you turned that into a fraction. Negative 1 over 1. What does negative 1 over 1 tell me to do? Down 1, right 1. Down 1, right 1. So from my big beginning point here, we're going to go down 1, right 1. Down 1, right 1. Down 1, right 1. And yay, they intersected. What is the solution point? 4, 0. 4 on the x, 0 for the y. I want to show you how to check. When we get this ordered pair, it was a 4 for the x and a 0 for the y. What we need to do is plug those points back in to the original equation. So what am I going to plug in for x? A 4 minus 2. And what am I going to plug in for the y? A 0. And it's supposed to equal 4. And we're just checking to see if the left and the right side balance. So I would multiply. What is 2 times 0? 0. And so we get 4 is equal to 4. The left and the right side balance. So I know I did that right. Now I only checked the first equation. I also need to check the second equation. So again, what am I going to plug in for x? A 4. And what am I going to plug in for y? A 0. And does it equal 4? Yes, it does. Easy. Do you have to check on paper, or do you think you could do that in your head? You can maybe do it in your head, especially like that second one. Super easy, right? 4 plus 0. Yes, it equals 4. So some of them you can check in your head. You can use your calculators to plug in and check. Okay, so it should be pretty easy. And again, you're just seeing, does the left side match the right side? Okay, let's try another. 2x plus 3y. I'm going to go ahead and separate these two equations. 2x plus 3y equals negative 3. And 3x plus y equals 6. And I'm separating them just because I have to get y by itself. So I need some room to do that. All right, so looking at this first equation, how do I get y by itself? Subtract 2x, subtract 2x. Now I'm left with a 3y on the left side. What's on the right? Negative 2x and a negative 3. A negative 2x and a negative 3 side by side. And then how do we get y by itself? Divide everything by 3. So we get y equals negative 2/3 x. And what's negative 3 divided by 3? Negative 1. Oh, good. Okay. All right. Where do we begin? Negative 1. B for begin. So we're going to go to the y-axis, and we go to negative 1. And what's my slope? What's that slope tell me to do? Down to right 3. I liked how you said the word to the right. That's very good. Down to right 3. Down to right 3. And I'm going to go in reverse as well because my line needs to go in the other direction. So I'm going to go up and back 3. Up 2 and back 3 as well. That first line, ladies and gentlemen, take the time to graph the whole thing. There we go. All right, now this one again, we need to isolate the y. So what should we do? Subtract 3x. So we have y equals a negative 3x and a positive 6, which is in slope-intercept form. So where do I begin? At 6. And our slope is negative 3. The number in front of the x is a negative 3. What does that mean for counting slope? No. Right 1. So remember, you want to turn it to a fraction. So we can do that just by putting it over 1. Down 3, right 1. Down 3, right 1. Down 1, 2, 3, right 1. Down 1, 2, 3, right 1. Yay! And we have our little intersection point that we hit. All right, what is that intersection point? 3 for the x and negative 3 for the y. Very good. That's what we're looking for. Where do they intersect? You should label that point. And again, I want to show you how to check. So I'm going to go back to my original equation, and I'm plugging a 3 for the x and a negative 3 for the y. So I would have 2, and in place of x, a 3, plus 3, and in place of y, a negative 3. And we're asking the question, does it equal that negative 3? So I'm going to multiply and get 6. And what's 3 times negative 3? Negative 9. And if you put those together, you would get negative 3, which definitely equals negative 3. So I know that first equation works. And I'd also want to check the second. And again, maybe you can do it in your head. Plugging in a 3 for the x and a negative 3 for the y. And does it equal 6? This becomes 9 minus 3. So yes, that 6 does equal 6. So I know it checks in both equations. Ladies and gentlemen, it is possible that it works in one and doesn't in the other. All right, when you check, which means you probably made a mistake in your graphing, okay? Or what we'll learn next week. All right, these last two, you can just watch. You don't have to copy the last two down, but I do want you to write down the result. All right, so sometimes we get solutions that intersect, and they intersect at one point. But two other things can happen. So first of all, I'm going to go ahead and graph this line because it's in slope-intercept form, so that's easy. So where do I begin? At 1. And again, if you just want to watch, that's fine. And what's the slope tell me to do? Down 3 over 4. You'll notice we take the negative and we put it with the top number. Down 3, right 4. So down 1, 2, 3, right 1, 2, 3, 4. And I'm going to go in reverse. All right. So here is my pink line. This other equation, what do I need to do? Subtract 6x. But we got to isolate that y term. So negative 6x and a positive 8. And then what? Divide by 8 everywhere. And so we get y equals, what happens with this fraction? You can reduce. Negative 3 over 4 with an x. And 8 divided by 8 is 1. And so where do I begin to graph this one? Oh, that's interesting. And what's the slope? Down 3, right. Oh, look at that. What are these two things? What are they? They're the same line, right? Okay, how many solutions does it have? Infinite solutions, because they are the same line They overlap in lots and lots of different places, right? An infinite number of overlapping points. Okay, this is infinite solutions because they are the same line. Will you write that down, please, in your notes? It is possible to get infinite solutions because they are the same line. Now, did I have to graph that to know these were the same line? No, I knew that right here when they had the exact same slope-intercept form, -3/4 x plus 1, okay? I want to see if we have infinite solutions. I want to see you write the reason why, okay? It's really important that you remember that they're the same line. There's lots of intersection points. All right, let's look at this one. My first line is in slope-intercept form, so where am I going to begin? At +3, and then what's the slope? Down to right 1, down to right 1, down to right 1, down to right 1. Okay, and I can go in reverse as well. So there's my lovely little purple line. All right, second equation, what do I need to do? Subtract 4x, subtract 4x. So we have 2y equals -4x minus 4. Oh, not 4, sorry, 6. And a -4x and a -6. And then we need to do what? Divide by 2, divide by 2, divide by 2. So I get y equals, what happens there? Simplifies to -2x. And then -6 divided by 2? -3. So here's my pink equation. So where do I begin? At -3. And the slope is down to right 1. Down. What are these lines? Parallel lines. So do they intersect? No. So what's the answer? No solution. Why? No solution because they are parallel, P-A-R-A-L-L-E-L, parallel lines. Ladies and gentlemen, write that down. This is the reason you're going to write down if you run into parallel lines, the answer is no solution because they're parallel lines. They do not intersect. There is no point that they have in common. All right, ladies and gentlemen, do you have a question for me? Lots of graphing today. And again, checking is optional, but you definitely want to know how to do it for the test. And we're going to be checking all next week too. Okay. So I'm going to pass out your worksheet. It's class practice 21. Wait, turn off the recording.